Hi everyone. Welcome to lesson 22, where we're going to talk about independent and dependent variables and graphs. An independent variable is independent of other variables. Okay, so not a very elaborate definition there. In other words, we assume it is not changed by other variables that you're trying to measure. This is a non-trivial definition to kind of wrap my mind around because in real life, it feels like everything uh, can be affected by every other thing, right? And so it really depends on what you're trying to measure, because if you're conducting a research study or something, you can't measure everything in one study. So it really depends on your individual situation and what you are trying to measure in your study. Once you figure that out, the dependent variable is what we assume depends on the independent variable. Now, that's a big assumption there because we could be wrong. Maybe the variable that we chose doesn't really depend on what we thought. So this concept, it's not trivial for sure, and it takes some time to really wrap your mind around what it means to be an independent variable and what it means to be a dependent variable. If you take a class in statistics, these same type of concepts will come up, and they mean very similar ideas. So let's look at an example, and we'll do a few examples. Let's assume you're trying to study how quickly babies grow. Okay, so that's what you're interested in, right? You want to know how fast, on average, do babies grow. So to study that idea, because there's lots of ways you can grow, right? You can grow in weight, you can grow in height, you can grow in language acquisition, right? There's lots of ways you can grow as a human. So let's pretend that you're studying babies' weight over time. So because that's what you're interested in studying, your independent variable is the baby's age, right? So their age is not affected by something else, right? You can't slow down time. It's not like I can stop somebody from aging. So we assume, in this case pretty safely, that age is the independent factor here. Nothing is going to affect age. The baby's weight, however, depends on their age. So because we assume that their weight changes as they grow, so it depends on how old they are, then weight is the dependent variable in this context. Now, it doesn't always have to be that the variable changes, right? Because once you get to a certain age, your weight may stay the same. You might stay the same weight for the rest of your life after you've, hit puberty and you're fully grown. So it doesn't have to be that the number is changing. That's not what tells you if something is dependent. It's whether it makes intuitional sense to you that that factor depends on the independent variable that you've selected. Many times when you're looking for some kind of relationship, you're trying to see if the independent variable causes some kind of a change. That's not always true, but if you're thinking about causal relationships, that could be true. For example, if you are thinking about the value of your car, so I have the best car in the world. I have a Subaru WRX. And the value of my car, if I wanted to sell it to you right now, it depends on a number of things, right? It depends on how many miles I have on my car, whether I've been in an accident, whether I've taken good care of it, whether I've souped it up, which of course I have. So it depends on all of a bunch of other factors that you could start naming. And so those other factors that you choose, they would become the independent variable. So it really depends on what you want to measure. But in this type of example here, related back to whether it's causing, so like you might say the number of miles on your vehicle is causing the value of your car to drop, or the wear and tear on your vehicle is causing the value of your car to drop. That's not always such a straightforward and easy claim to make, but if you take more advanced mathematics classes or statistical classes, you'll study more of that. And so that's why I mentioned that it is important to understand the difference between independent and dependent variables, because when you do certain types of studies, you might be looking for if the independent variable is causing some change in the other variables. Okay, the last thing about this topic is that a variable must be measurable. This means when you define a variable, it has to be something that can be measured. For example, a car's value depends on the mileage of the car. The dependent variable here is the car's value, and the independent variable is the number of miles. So look at the way I have defined the variables. I said the dependent variable is the car's value. I didn't just say the car. And the independent variable is the number of miles, right? I didn't just say it's miles. So it's the number of miles that you have on your car. So these are very important, non-trivial ways that you're defining what's happening in this situation. And the most common mistake I see students make when they're asked to state the independent or the dependent variable is they will say things like, oh, it's the car, or it's the baby, instead of being specific about what exactly are you talking about that can be measured about the attribute that you just listed. So there's many things that can be measured about a car. So if you just say that the independent variable is the car, that's incorrect. You have to be specific about exactly what you're measuring. And the more specific you are, usually, the better the research study is if you're doing something in statistics, right? So if we can be very specific about exactly what we're measuring, then the claims that we make, that we then give to the population, will help us to make more informed decisions about what your study just showed us exactly. Okay, let's try some examples. So just determine the independent and dependent variable for these two situations. For the first one, a person's salary typically depends on their age. And so I say typically because usually if you're not at least 16, usually you don't work. So you don't make any money. And after that, usually the older or further you advance into your career, which usually comes with age, the more money you make. So if a person's salary depends on their age, which of these variables is independent and which is dependent? Now the keywords here help you. This depends on right here, if I bold that, those are keywords. There's a person's salary depends on their age. That means that a person's salary is the dependent variable. And you can hear it because of the way the sentence is worded. We just said the salary depends on, and whatever it depends on is the independent variable. So it's easier when you can find that relationship and state it in some way that shows you which variable depends on the other. Why don't you try number 2? Number 2 is missing kind of that key phrase. So maybe try to fill it in for yourself to see if you can figure out which variable is the independent and which one is the dependent. Okay, so the average cost of tuition to attend college has been increasing since 1980. I don't think there's any secret there. So which one of these is the independent variable? Well, usually when I think of time, that's not something that I can control, right? Like the years are going to pass. I can't stop time. So this means that the years since 1980, is the independent variable. That the years will just keep counting, right? Whether I study something or not, the years are going to continue. So nothing affects the years since 1980. But the cost of tuition, lots of things affect that, like how many people are going to school, whether inflation is occurring, whether you go to a big university, whether you go to a small university, whether you're in-state, out-of-state. There's lots of things that affect the cost of tuition. So that means the average cost of tuition is your dependent variable because it depends. The actual cost of tuition depends on lots of other things. And one of those things is what year you're talking about. So the cost of tuition in 1980, I would expect, will be different than the cost of tuition in 1990, and different still than 2000 and 2010 and 2020 and many other years. Okay, so again, this is showing that the average cost of tuition to attend college depends on the years since 1980, the years that have passed since 1980. So notice you can't just say here, don't just say years, because we're talking about since a starting point. So you have to make sure you specify that 1980 is the starting point. Okay, So those were, now remember, this type of concept is not trivial. It's difficult. It requires lots of practice to wrap your mind around. So these next two examples, I didn't give you the actual sentence. So now you have to think for yourself, use some of your common sense to determine which one of these variables depends on the other. So temperature, and by temperature, I mean like the temperature outside, not the temperature of your house or something. So the temperature outside compared to ice cream sales, which one of those is the independent variable and which one is dependent? And then the price of a pizza and the number of toppings on the pizza. So pause your video and try these two now. And I'm going to write a sentence so that I can wrap my mind around what depends on what. So temperature does not depend on ice cream sales. It's not like if I sell more ice cream, I can make it warmer outside. Boy, I wish I could do that because I'm a beach volleyball player and I love the heat. And so I would love it if I could just sell people ice cream. All of a sudden the temperature would rise. That would be great. And then I could prevent it from snowing and I wouldn't have to shovel, all kinds of miracles. But that doesn't happen. Instead, what happens is ice cream sales depend on the temperature outside. In other words, when it's colder, people tend to buy less ice cream. They don't want to make themselves feel colder because they're already cold. And when it's warmer, people tend to buy more ice cream. So because of the way we just said this, there's your phrase. If ice cream sales depend on something else, then ice cream sales are dependent variable, and the temperature outside is the independent variable. Again, another way to think about it, that is like the temperature is sort of out of your control. It's not influenced by other variables to a certain extent. It's not influenced by variables you're interested in studying. That's a good way of saying that. Okay. How about this last one? How about number 4? So the price of a pizza depends on the number of toppings that you order. All right, so that's usually true. Usually, if you order a pizza that has more toppings on it, it's more expensive. It's like each topping is like $2 or something. So there we go. So we have the structure in our minds that the price of a pizza depends on the number of toppings you order. And once you know that, let me make this one line so it's easier to see. Once you know that, then you know which variable is the dependent variable and which one is the independent variable because of the way you just wrote it. So the price of a pizza is the dependent variable, and then the number of toppings is the independent variable. Another way to think about this is you can control the number of toppings that you order, but you can't control the price of the pizza. So based on how many toppings you choose to order, that will determine the outcome of how much your pizza will cost. So I'm trying to say these in as many different ways as possible so that you really can wrap your mind around what it means to be an independent variable and what it means to be a dependent variable. For sure, though, it is not whether the value increases or decreases or changes, because you could have something that's constant, right? You could have like somebody's height over time. It's eventually going to level out. And so it doesn't matter if the height is increasing or decreasing. It's this idea of like, does it depend on blank? Or is it influenced by this factor? Or can you control this factor? Those are the kinds of questions I think about. So now that you have a rough idea of what independent and dependent variables are, and be patient with your learning, give yourself time for that idea to make sense, we're going to move into talking about graphs. So there are several ways to express a relation between two variables. You could use a table like this, or you could use a graph like this, or you could use an equation like this. When you're creating a mathematical graph of a situation, you have to pay attention to which variables you're measuring. The graph is not a picture of what the situation would look like if you were to take a video of whatever's happening on your phone. That's not what the graph is. And this is a very important concept to internalize. The graph is measuring how the independent variable is related to the dependent variable. So that's what the graph is measuring. It's not a picture, it's not a video of the real life situation that would be occurring. So I'll give you an example. I'll do number 5 with you, and then you'll try number 6. So Brian rides down an elevator towards the ground floor. Let's find the graph below that shows this relationship between Brian's distance above the ground over time. Now, there's one more thing I want to tell you about independent and dependent variables. When you look at graphs, typically the independent variable is on the x-axis, so the independent variable is the x variable, and the dependent variable is the y variable. And the reason why we do it that way is because our eyes naturally read from left to right, so it makes it easy for us to see how the dependent variable is changing as the independent variable increases. Okay, so Brian rides down this elevator, and he's going down towards the ground floor. The correct answer here is not this last graph. And that's what I mean when I say it's not a picture or a video of what the situation would look like. So if you were to think about, I'm going to make my camera bigger and draw a picture up on the whiteboard here. So if you were to think about somebody riding down an elevator, you might think that they're, here's the elevator and here's the happy person, and they're going down. And so the video of this happening would be like a line going down. That's not the mathematical graph, though, comparing the relationship between those two variables of distance above the ground and time that has passed. So one thing you can do to think about this relationship is you can pinpoint moments in time. Like maybe let's pick 3 various points in time, 3 random points in time. And then think about what would his distance be at that point. So let's start at time 0. Like he's in an elevator. He's obviously above the ground floor because he's going down. So his distance, at time 0 might be 10 feet. I'm just making up a number. So at time 0, let's pretend, here you go. Here's 10 feet. There you go. So there's the point, 0, 10. Showing that at time 0, he's 10 feet above the ground. And now he's going down. Okay, so then let's say, I don't know, how long does it take you to ride in an elevator? Maybe 5 seconds, depending on how high it is and how fast the elevator goes. So let's say that after 2 seconds, if you were to draw a new picture, right, let's say he's now down here. Like now he's moved down a little bit. So now his distance is right here. So it's only, let's say, 7 feet. So after 2 seconds, now he's only 7 feet in the air. So there's a second point in time. And let's say it takes him 5 seconds to hit the ground. So at the 5-second mark, he is then all the way on the ground in the elevator. So here's 5 seconds, and on the ground means your height is 0 above the ground. You're on the ground. So here it is. Here's the function that would represent Brian riding in an elevator heading to the ground floor. And this function is measuring his distance above the ground over time. It's very important to pay attention to what variables you're measuring, because if I put a different variable on there, then this graph would look different, even though the situation would be the same. For example, let's add one more example to really make sure you understand. What if I said, measure his speed, his velocity, over time? Now that's a very different graph. His velocity over time, well, if you want to do velocity, velocity is speed, but it includes a direction. So if the speed is going down, usually that's a negative value. If the speed is going up, usually that's a positive value. So maybe let's simplify that so we don't have to get so much physics involved. Let's just talk about speed. So if you're measuring his speed, I don't know if he's already going down when we start measuring this, or if he's stopped and then hits a button and then he starts going down. So let's assume he's stopped. So if he's stopped, then at time 0, his speed is 0. That is already a different graph than this one, because that point is different. So then, usually what happens in an elevator is you pick up speed I mean, you kind of pick it up a little slowly, and then all of a sudden it starts to really start dropping. So you pick up speed a little slowly, and then, you know, at a certain point you maintain a constant speed. The elevator is moving at a constant rate. And you feel that in the elevator, right? Because you can feel when the elevator first starts to go down, you're like, woof, like I hang on to the bar. But then after maybe a second or two, I can let go, and even though I'm moving, it doesn't feel like I'm moving. That's because I'm not accelerating anymore. I'm at a constant speed. That I'm traveling in the elevator at a constant rate. And then at the very end, you know, the elevator hits the ground floor, so it comes to a stop, so the speed must come back down and stop. Okay, that's a very different graph measuring the same situation in real life. So hopefully this really drives that point home, that the mathematical graph, it's not a video of what you would see if you were watching the situation unfold. It is a relationship between the dependent variable and the independent variable. And it is a graph. Are you ready for this? It's a graph that consists of infinitely many points. So how many points are on this graph? An infinite amount. You cannot count how many points are there. How many points are on this graph? Well, you might say, well, we plotted 3. Yes, but how many points are now on this entire graph here? And infinite. There's a point at every single value in between here. Like, I literally can't sit here and graph all the points because there's an infinite amount. So that is what a relationship is in mathematics. It consists of an infinite set of points showing the relationship between those two variables. Okay, so we're going to practice a problem right now to see if you can understand that concept. All right, so in other words, for the one we just did, the correct answer would be B, the second graph. If you want to call them A, B, C, and D, it would be B. All right, for number 6 here. So an archer shoots an arrow at a target. Choose the graph that shows this relation. Okay, so I want you to pause your video. All right, make sure you can see these 4 graphs. And which one, we'll label them A, B, C, and D, right, from left to right. So A, B, C, and D. Which of these graphs shows the arrow's distance to the target over time? You're measuring the arrow's distance to the target over time. So try this problem now. Okay, so it might help. I'm going to do the same thing I did for the previous problem up here. So I'm going to make my screen a little bigger again. And let's draw a picture of what's happening with the understanding that whatever that picture is, that's not necessarily the mathematical function. Okay, so we're going to erase all of this. And let's see. You have an archer shooting an arrow at a target. So you have someone standing here, you know, they're holding this arrow. I'm a great artist. There we go. Okay, let's get this, I don't know. Let's hit this target. Here we go. Okay, so here's a target. And so the archer is standing some feet away and then lets the arrow go, and then the arrow starts to make its way over to the target. Well, hopefully, if you're a good shot, hopefully you hit the target. If it were me, I probably wouldn't. So, what are you measuring? And that's the key, right? That's always the key. What are you measuring? So let's come back here and check. The arrow's distance to the target over time. Okay, the arrow's distance to the target over time. So let's start at time 0. Here's time 0, where you're holding that you haven't let the arrow go. So how far are you from the target? Well, it looks like you're a decent way away from the target. I mean, you can make it up, right? 20 feet. It doesn't matter. You're just sketching it anyway. So distance to target. All right, so at time 0, you should be somewhere up here at 20. Now, think of another point in time, and then think about how far away is that arrow from the target? So let's go with 2 seconds later. How far is the arrow? Well, after 2 seconds, maybe the arrow is right here, right? So if this takes 2 seconds, that's very unrealistic, by the way. I think it only takes 2 seconds to hit a target, but that's okay. For all intents and purposes, it doesn't matter. So let's say after 2 seconds, now you're 10 feet away. All right, so here's 2 seconds, and here's 10 feet now. And after 4 seconds, let's say you hit the target. So after 4 seconds, what is your distance from the target? Well, now your distance is 0 because you're on the target. So there's no line I could draw showing the distance because you're there. So here you go. After 4 seconds, you have hit the target. So it looks like this. That's a rough sketch of the arrow's distance to the target over time. And the way we did this is I just made up some values in my head to think about how this variable is changing according to this variable. That's the key. That's the key that you're doing right there. Anytime you look at a graph, you're analyzing how is this variable changing as this variable increases. Okay, so that was a lot. There's a lot in this lesson. I know it feels like we only covered 2 things, variables and graphs, but there's a lot to talk about with those 2 things. So you're going to do some extra practice now. So what I want you to do is go to Desmos, for those of you that are my students that are not watching on YouTube. So, and if you already joined our class on Desmos, then you can just click Go to Student Homepage and then just sign in right here. If you haven't joined our class yet, then go ahead and enter your class code. So it can be found in multiple places. It's on my syllabus. It's probably also listed on Canvas or whatever I'm using. And once you sign in, so you will see, let me go to one of my classes, you will see an activity called Graphing Stories. So you're gonna go to Graphing Stories, see if I can open the student page for you. Okay, I'll bring this down a little bit. And so in this Desmos activity, you're going to watch a video. So you'll press play and you'll see a video. You'll answer some questions about what things could you measure here. And then when you go on to the next screen, you are going to sketch a graph where somebody has given you a dependent variable here and an independent variable here, and you're going to press play and try and graph the relationship between those 2 variables. Now there's a couple things I want you to note before I let you go and do this. If you press play, do you see this dotted line here? Now let me pause the video. See how I just paused the video? And you can use this pencil tool to put just a single point, like I can put a point there. Let's say if I press play again, I can stop it. You know, I could put another point somewhere else. I could connect these with a straight line if you think if the relationship is linear, then you could connect them with a line. Or if it's not, you can, I can undo here and I can just sketch, however I think these points should be connected, right? So that's a very rough sketch because I'm using a computer mouse and not a freehand mouse. But you can do that. You can erase just one part of it, or you can just delete everything you just did. You can back the video up. So remember, I said each graph that you see, it's really just an infinite collection of points. So one strategy that students use to sketch a graph of this relationship is they'll plot a lot of points over time, whatever your independent variable is, and then they will sort of, connect the dots, so to speak. Okay, and then on the next screen, you will see the answer. So there's my graph, and then if you press play, which I won't do yet because that's for you, you will see the answer. So you're going to do this Desmos activity, and there's like, I think 5 different relationships that I want you to graph. So you're going to watch a video of something happening, and then you're going to sketch a mathematical graph. Every time you do this, pay attention to the variables. Try and make your sketch roughly accurate, but it doesn't have to be perfect, but think about if it starts at 0 or if it should be somewhere above 0. Think about how quickly this should be increasing. If you think it's increasing, like this is increasing, not as quickly as something like this. So keep those things in mind and try and make it as accurate as you can. And then on the next slide, there will always be the answer so that you can compare your work that you just did with the correct looking graph for the situation. Okay, so good luck with this lesson. And if you have any questions, please don't hesitate to reach out to me.